Software development is an ever-evolving field, with new technologies and techniques being introduced every day. One of the most important concepts that developers must understand is the solid principles of software development. In this clip, we will explore what these principles are and how they can benefit software development. We'll also look at some examples of solid principles in action and best practices for implementing them. The solid principles are a set of 5 principles that are used in software development to ensure code quality and maintainability. The acronym stands for Single Responsibility, Open-Closed, Lisk of Substitution, Interface Segregation, and Dependency Inversion. These principles are used to help developers create code that is both flexible and scalable. The solid principles can be a valuable tool for software developers. By following these principles, developers can create code that is both maintainable and extensible. This can help ensure that code is easy to manage and can be quickly and easily modified when needed. Using the solid principles also helps to reduce the amount of time and effort that it takes to develop and maintain code. This can help developers save time and money, as well as reduce the risk of errors and bugs. Let's start analyzing each principle one by one, starting with the single responsibility principle. The single responsibility principle states that a class should only have one responsibility. This means that a class should only be responsible for one thing and should not be responsible for multiple tasks. This helps keep code organized and ensures that code is cohesive and easy to maintain. Let's have a look at this code here. This report generator class breaks the single responsibility principle because it handles database connection management, establishing and terminating the database connection, data retrieval, by executing the query and fetching the data, and report generation by processing the data into different formats like CSV or PDF. Refactoring it with the single responsibility principle in mind, we will have a class for each responsibility. Each class now has a more focused purpose. Moreover, changes to data retrieval won't affect report generation mechanisms and vice versa. There's also increased testability as you can easily write unit tests for individual components. Moving on, open-closed principle. The open-closed principle states that code should be open for extension but closed for modification. This means that code should be written in such a way that new features can be added without having to modify existing code. This helps ensure that code is maintainable and can be easily extended when needed. Have a look at this code. Feel free to pause the video and try to find how it can be optimized. If you need to add a new customer type, for example Platinum, you'd have to modify the calculate discount method directly. This change can potentially introduce bugs into existing logic. Here's a refactored version of this code. Now, to add a new discount type, you create a subclass of discount policy without modifying existing code. The core calculate discount logic remains untouched by new customer types. Lastly, you can easily change the discount policy at runtime by injecting a different discount policy into the discount calculator. Let's now illustrate the Lisk of substitution principle with a Java example. The Lisk of substitution principle states that a subclass should be able to replace its parent class without changing the behavior of the program. This helps ensure that code is extensible and can be easily replaced when needed. Now let's see why this code is bad. A client of the bird class expects that all birds can fly. Subclassing penguin from bird breaks this expectation, which breaks the Lisk of principle. To counteract that and to ensure substitutability, subclasses shouldn't expect more from their inputs than the base class. Subclasses shouldn't produce less than what's guaranteed by the base class. Subclasses should maintain the integrity defined by the base class. How about the interface segregation principle? This principle states that a class should not depend on methods it does not use. This helps ensure that code is cohesive and organized, and it helps keep code maintainable. When following the interface segregation principle, developers should ensure that classes only depend on the methods they need. This can help ensure that code is organized and that it is easy to maintain. In addition, developers should ensure that classes are properly tested to ensure that they do not depend on any unnecessary methods or functionality. This can help ensure that code is maintainable and extensible. Let's have a look at some code here. The animal interface forces classes like dog to implement irrelevant methods, potentially leading to exceptions or nonsensical behavior. It also shows reduced flexibility. If we introduce a new animal, say bird, there's unnecessary coupling, even though a bird might not need to swim. Now, let's see this refactored code. We have smaller, more focused interfaces tailored to specific capabilities. There are no unnecessary implementations. Classes like dog and bird only implement the interfaces that make sense for them. Also, the code demonstrates enhanced flexibility. New animal types can easily be introduced and use only the combinations of interfaces they need. Finally, the dependency inversion principle. This principle states that dependencies should be inverted. This means that code should depend on abstractions, not concrete implementations. This helps ensure that code is loosely coupled and can be easily modified and extended when needed. When following the dependency inversion principle, developers should ensure that code depends on abstractions, not concrete implementations. This can help ensure that code is loosely coupled and can be easily modified and extended when needed. Let's see a real-world implementation for this principle. Notification Manager is directly dependent on the concrete implementation email service. This makes it difficult to change the email sending mechanism or to unit test Notification Manager in isolation. In the improved code, we can see the following. Notification Manager now depends on the messaging service interface, not a specific email implementation. You can easily swap email service with a different implementation like SMS service, as long as it conforms to the messaging service interface. The solid principles are a valuable tool for software developers. By following these principles, developers can create code that is both maintainable and extensible. This can help ensure that code is easy to manage and can be quickly and easily modified when needed.